Okay, first off, I need everyone to make sure you have IntelliJ opened and ready to go. When we run through a couple of examples here today, I want to make sure that you guys can be right there with me, all right? Let's talk about classes and objects today. Classes and objects are very important when it comes to understanding how we store data on a computer, okay? Again, I'm going to remind everybody in the class, please be doing this class and nothing else, okay? If you're surfing the web watching videos and they're in the back, okay, Elijah, you got to be focused on this class, okay? All right, thank you. Objects are a way we store data in a program, okay? So you guys are familiar with ints, shorts, bits, bytes, right? Longs, doubles, floats, strings, booleans. All of those are considered what type of data type? They're primitive. And do you know why they're primitive? In Java, they're not considered objects, okay? They're primitive because they're not considered objects. But the way those data types are stored in the computer, they're stored in memory. So I've talked about this a little bit. When we actually create a class and we run it, we're actually taking up a specified amount of memory on your computer, okay? So when we create a class then, and then we instantiate that class in another class, it becomes an object. So the key there that I want you to remember is when you create a class and you instantiate it in another class, it becomes an object, okay? And that object, its definition, its data type, all the details about it are defined in the class that you created. So let's take a look at some ideas we have here with objects and classes, okay? Classes can be, as the slide here is saying, classes can be differentiated in two types. We have instantiated, we have objects which are not instantiated from classes, and then we have the objects that we create from classes. The idea in an object-oriented programming language is everything is an object. So Java is not technically 100% object-oriented, is it? Because not everything is an object. You have primitives. But the idea is that an object will have a relationship with its class. Let's break it down into the idea of Bill. All right. What are some attributes that describe Bill? All right. Let's just say a person in general then. Okay. A person has they have an eye. They have two eyes. Hopefully they don't have more than two eyes, okay? A person has ears. Person has hair, some type of hair color, or if you're Bodzu, it sucks to be you, right? A person has eye color. Person has height, right? These are all attributes that describe a person. So if we were to create a person class, we could probably capture some of those attributes. More generally though, if you look at like in a database, what attributes do we generally define in a database concerning a person? Name, last name, birth date, address, right? Those all consist of is a relationship. So those elements, they have this is a relationship to the class itself, okay? So an object then is an instantiation of a class. So if we create a person class, and I use that person class, say in a gradebook program, I would say I'm adding this person, I'm instantiating this person and adding them to my gradebook, right? I'm instantiating, I'm adding them in memory, right? Objects and classes, they give you the idea then of reusability. If I create an object, well, now I can reuse that object in different places. We're going to see some examples of that, and I think hopefully you guys have seen some examples of that if you've already started your homework this week. There's an assignment, the very first one is creating a sandwich. Did y'all see that one? Yeah. And then you have to test the sandwich. So you're actually instantiating the sandwich. You're instantiating it, providing the main ingredient, the bread type, right? Things like that. Any questions so far on this? The key here is think of, if you think about these objects that you're creating and you're modeling in code, they usually model to some type of real life scenario. And later on, if you get into programming and this becomes what you do in life, the functional, what do they call these? Our functionals, our customers will sit down with us and say, this is what I want to create. And you begin to kind of dissect it and already think, all right, we've got to create this type of object. We've got to represent it with this kind of data. This is maybe how I'll map this data to the database. And objects, and a lot of times, they become really great models for how we map things to the database, because you have a lot of these characteristics that we can think of in creating a table, right? A class can instantiate another class, and that class could be used by another class that instantiates that class, and so on and so forth. Everything becomes objects that are reusable. All right, let's do a quick knowledge check. An object is a blank of a class. What do y'all think the answer is? It's an instantiation of a class, okay? An object is an instantiation of a class. Here they're giving an example. Goldfish, my guppy, the zoo shark, each constitute one instantiation of the fish class. Right? So we could create a fish class, and the fish could have a name, right, and carry some different attributes. And we could say that when we create this fish, we're going to call it the variable name we're going to call shark, and provide it the details. This one we'll call guppy and provide it the details, right? So class headers usually have an optional access specifier. All right, so what is the access modifier for a class? Public, private, right? Protected, right? Or you have default, which is that nothing is specified. All classes are going to include the keyword class in it, okay? That's how we know it's a class. And they have to have legal identifiers. Rule of thumb is that the class should begin with an uppercase letter. That's the rule of thumb. Requirement is that they begin with letters, okay? You can't begin a class with a number. Technically, you could begin it with a special character, but you just slap yourself if you ever do that, okay? Legal identifiers. So public class, as it says here, is accessible to all objects, and public classes can be extended, all right? And then you have the data fields. Data field components of a class distinguish from one variable you might use. Instance variables. One copy exists for each object instantiated. All right, so let's kind of take this out of the theoretical from me talking about it to now doing a little exercise. We'll go ahead and open up IntelliJ. And what we're going to do is we'll create a new project, and we'll call this transportation. Just made that up off the top of my head. All right, transportation. So I've got a simple class that I've created. Okay, it's called transportation. And inside of it, I'm going to create a new class. And let's call this class, no, car could be too specific.
Everything.
Believe it or not, that's too specific.
I guess just land.
Let's just call it
Wagon.
automobile. All right. So we have some basic things here defining an automobile. Let's go ahead and go with a private, and we'll call this string. And let's do the automobile as the make. Private, string, and then we'll have the automobile's model. Right? Private, string, and we're going to do vehicle type. Actually, yeah, we'll leave that as vehicle type. We'll get into another way to create this automobile class later, all right? Now, typically at this point, this class has what we call a default constructor. Can someone tell me what the default constructor for this class is? Yeah, it's automobile. If you were to type it out, what would it look like? Give me the default constructor here. It's automobile, right? That's the default constructor. So when I instantiate this class, if I had not specified a constructor, it uses this automatically, the automobile constructor. Okay? All right. So we have this automobile. Let's go ahead now and think about information hiding. This is another concept of classes. What information right now am I hiding about this class? Looking at it right now, tell me, what information am I hiding?
Everything previously stated, like the make, model, and vehicle types, it's all private.
Very good. They're all private, and so private means it cannot be seen outside of the class. Now this raises the question for many of us, why would I make it private if I don't want someone to see it outside the class? Well, in programming in general, we have this concept of immutability, right? We don't want things to mutate in a way that is beyond what we expected. Mutate means to change, okay? Immutability means no change. So if I don't want these variables to change in a way that I don't think they should change, then the best way to do that is to provide their instantiation through the constructor. If I want them to change after the object has been created, then I would provide a setter. Let me demonstrate. We're just going to demonstrate this real quick, okay? So in IntelliJ, we can do, let's see, what is it? Code. I'm trying to remember the keyword. Generate. All right. So you can do Command N or whatever, and then you can go to getters and setters. okay? And I'm going to go ahead and select all three. And I have all my getters and setters created. Now, keep that topic of immutability in your head for a moment. Okay? Keep it in your head. If something is private, it can't be seen. If something is public, it can be seen. So what I've done by providing a getter and a setter is I've provided the methodology I want the user of this class to use for modifying those variables. So how am I allowing them to get the make? I'm giving them a method, a public method, that they have to use to get the make. How am I allowing them to set the make? I'm providing a method that takes make and assigns it to make. Okay? All right.
Sorry, so can we go over that whole, that bit that you just did? Or is that pertinent to what we're about to do?
How I generated these?
Yeah.
Okay, so in IntelliJ, this is the way that makes your life easier and prevents you from making a lot of mistakes, okay? You do this, you go, you can right click, go to generate, or if you know that little code, see the code for by generate on a Windows, I think it's like Command in.
It's like Alt Insert.
Alt Insert on Windows. Okay, on a Mac, it's the Mac key and in. Okay, but nevertheless, once you click it, you get this other little window, and just select Getter and Setter, and then you can select what you want to be created, or you can say I don't want anything created. Okay, but we're going to have all of these created.
Wait, it's not linking. String is not linking.
Okay? All right, so we've created.
Yeah, something's wrong. It's red.
Okay, we can talk to you after class about it, okay?
Okay, got it.
All right. I do want to encourage you to go ahead and shut down that video you're watching, okay, and pay attention to what we're doing. Okay? All right. So, we've created these methods. We have what is called a getter, and we've got a setter, okay? I'm getting the property that's hidden right here. You guys understand so far?
Yes.
Okay, any questions so far about these key ideas? All right. So we're talking about information hiding. I'm hiding this information and I'm controlling how it's made visible through a getter and a setter. I control how it's mutated through a setter. Now, I'm going to tell you this. Best practice when you create a class is not to use setters. The reason is that if you want the data that's in that class when it's instantiated to be self-contained, then you do it through a constructor. If you don't do that and you use setters, you basically now have an object created in memory that can be mutated through a setter. Best practice is that we don't do that. Okay, that's best practice. Okay? But you guys are learning, so you can do anything you want. Okay? Just don't hurt yourself. All right? Okay, so for our purposes, we're going to follow best practices. Okay, I'm going to go ahead and delete all of my getters and setters again. Once you get comfortable with this, use the generate command. This time we're only going to create getters. Okay? All right. So now I have my getter. For my default constructor, I'm going to wipe it out because I don't want my default constructor to be available to everyone. I want to force the person, when they create this car, to use the constructor I want them to use. Okay? And I want them to use a constructor that uses all of these variables. So let me go back and do it again. Right click, go to generate, click constructor, and then select the properties, these variables. Okay? When you do that, it's going to automatically create a constructor with these variables. Okay? Now, if you're typing this out by hand and you're not using the generate functionality, what's going to happen probably real quick is you may misspell something, and spelling matters in Java. If you misspell the variable name, you're going to get these little red curlies, and you're like, why is it not working? Right? Yeah, it's... What's that? Okay.
Is
Yes?
there control find? Because I know what it does is that, find the words. So
Yeah, you can just find it at the top. Right? If you do Control F, you can do find. Okay, so I've created this class. So now I'm going to do another class. Now keep in mind, my model, I don't have a year on it, but this is just demonstration, okay? We could add a year to our model, to our data model here for our automobile, but we're not worried about that right now. I'm going to create another class, though, and I'm going to call this class my automobile list. Okay? So, I'm going to create a private list of automobiles. You're kind of getting something early on here. Okay, make sure you import Java util list when you do this. And this is my cars, or my cars, it doesn't matter, equals new, and we're going to call it array list. Okay? All right, so I've got this collection of cars. So let's think about this. I'm going to add a car to my collection of cars. So I'm going to do this. I'm going to say let's first of all do this. Public static void main, right? Main method, string args, okay? And we're going to use the automobile list inside of our class, and it's going to use the automobiles that we created. All right, because we're inside of a static method, I have to instantiate this as an object. And the way we do that is we say automobile list, my collection equals new automobile list. All right, you'll notice right here, I'm using, for this class, I'm using the default constructor. Does everyone understand? Okay, everyone say default constructor. Yeah, you're back in first grade again. All right. Default constructor. Now I have created this now as an object that can be reused in my class. So I've got my collection, and I've got my cars. And then I'm going to say add. And we know that this list object uses something of type automobile, so I need to say new automobile. And IntelliJ is telling us right away what we need to add into our constructor. Can you see that? This is a nice thing about using an IDE, because the IDE is going to say, hey, you need this constructor requires a make, a model, and a vehicle type. All right, so favorite vehicle, someone.
Mazda Miata. Model T.
All right, someone said Ford GT, so we'll go with the Ford GT. And what vehicle type is this? It's a sedan, right? Okay, so there we go. Now I'm doing a couple other things here for readability, right? I've got my cars add, and there we go. All right. So I am creating an object here, right? And what's the name of my object? My cars. It's of type list that's designed to take an automobile that I created, right? So that's where it's going to create in memory. It's going to organize the data and say, this is how the data is going to be stored in RAM. Okay? It's kind of hard to wrap your mind around that, but if you think about, okay, even to the constructor design in memory, this is the data it's going to store in RAM. Literally going to store it in memory like that, right? But it's all going to be bits, ones and zeros. And then this instantiates another object called my automobile. All right, let's add another one. I'm going to take my collection, my cars. I'm going to add another one. What type of car am I going to add here? You want to? That's your favorite car, huh? Ford. I don't know. Is it just Model T? I think it's just the T, isn't it? I don't know if it matters. All right, what is that? Is that a truck? Is it a sedan? I don't know if there's a classification for a Model T, right?
No.
We'll just say sedan, because its chassis is a little bit different. All right. Take out that semicolon there, because I already have my semicolon here. All right. So I have this data that I've created. All right, let's go back now to automobile class, and let's add a method. We're going to call this public void display. Public void display, and we're going to do a system out print line, and we're just going to print out the data of this object. Okay. We're going to say make plus space model plus quote space plus vehicle type. And what I'm going to do to make this a little bit easier to read when we do this is I'm going to put in here make model and type. Okay? Make, model, and type. Okay, let's go back to our automobile list class. Are we all good so far with everything I've typed? You guys are with me? Okay. So if we go back, uh-oh, Bond, did I switch too quick on you? You got it? All right. I don't want to go too quick. There we go. All right, so we're going to go back to our automobile list. I've got this, I've got this thing going on here. I'm going to create another method. And this method, right underneath my list, is going to be public void show cars. Okay? And I'm going to introduce you to a collection. We're just going to use a simple for loop. Okay? For, and I'm going to use specify the type. And then the collection. And then I'm going to say mobile display. All right. We'll get into how this for loop works later on. But for right now, you kind of get the idea. As I iterate through each type of car stored in this collection, I'm going to call the display method on that car. Okay? Now, all I have left to do is come down here and do my collection, show cars. Right? Okay. So I'm going to click on my terminal. And you guys get in the practice of compiling it both ways. Don't just lean on your IDE, okay? CD into your source directory. Okay? We're going to do javac automobile.java first. Okay, and then javac automobile list second. Okay, order is important. If you try to compile one before the other, you're going to run into an error there because you're using two classes. Okay, and I'm going to do Java automobile list. Okay, and then it runs. Right? Now you can imagine other things that we could do here. We could use a JOption input, right? We could input the data that way. We could use a scanner to input the data. And then, of course, all we're going to do is just print out the data. All right, so there's a couple of things that we did here that some of you might be scratching your head about. Let's go back to the automobile class. And let's go down to over here to the constructor. There's a special keyword here in this class that identifies something special. Does anyone see what it is? This. Yes. Does anyone know what this is?
That. I think it's referring to the class itself. I want to say it makes it more specific for targeting that by saying this. Like, I'm legitimate, I'm trying to answer this.
This is referring to the object itself that's about to be instantiated, right? It is referring to the class, but it's this. Anytime you use this in code, it's referencing, like Chris said, the class itself, but it's referring to the properties of that class. Okay? Properties of that class. All right. Let's pause here for a moment. And I don't think there's anything else I need to discuss here. Let's go back to our slides just for a moment. All right, so we have our instance variables. In this class, this is an instance variable, right? In the automobile class, these are our instance variables. Guys understand? And these instant variables, they have things that they refer to, right? Over here in the automobile list class, I have a list type that allows me to use other objects. And it itself is an object referring to an object, right? These are instance variables. All right, let's go back. All right, so we talked about private access. We have information hiding. And the importance of creating private access. Private data, we only want change by our own methods, okay? So if I'm over here in this class, because I've made these variables private, and the only place that I can adjust that variable is with the constructor. That means right here, when I create this object in memory, that object in memory is immutable. Can't change it. That's powerful, okay? Can't be changed. I can replace it in memory, but I can't change it, okay? Now, if I come over here and I do this instead, setter, and I say we're going to make the vehicle type immutable, well, this gets a little weird then. I could come down here and I could say my collection, I could literally do this. Let me show you what I'm going to do. I'm going to do a for loop, and I'm going to specify another automobile. And I'm going to take my cars, and I could say automobile set vehicle type, and I could say make them all trucks. Now I've mutated the object in memory, and hopefully you can see the problem with that. Okay, you don't want to allow mutation of your object in memory. There are some use cases where that's acceptable, but 90% of the time, 99% of the time, keep your objects immutable in memory. Okay. All right, let's go back. Information hiding. Right. We can even hide our own methods. So in our class, we can make, say we have a special method in here. We want it to be private. We could make, and this instead of public, we can make it protected, right? And it's okay here, but anything outside of the compiled classes that use each other, they couldn't use the display method. I'm changing the properties of how it's accessible. Okay, let's go on. So when you create a class, you instantiate the objects as private. If the class's methods are static, they're not instantiated. Okay, you're just using them. You're not creating space and memory. So there are some instances where you want to keep the instance itself unique in memory, but usually you don't want to do that. You want to keep it. You want to instantiate new objects in memory and not use the static. Okay. So you got fields, you got methods. We talked about mutator methods. Everyone know what a mutator method is? Yeah. The idea here with the setters, we understand we're just basically prefixing a method with set to mutate that variable, right? Right? Any questions so far in the way these are laid out, these methods? What is the return type of this right here?
And, no?
It's void, right? Because the return type is specified, it doesn't return anything. Here we have a return type specified of int. Now this is important. You must return if you have a return type. Okay, you need to do that. Okay, so you got non-static methods used with object instantiations. These are called instance methods, right? So example of that would be over here in my automobile list. I call the instance method of this class, my collection, right? So automobilist is the class name. The variable name is, this is the instantiated instance. And I call the instance method of it, right? You can do things as static or non-static as well. So we could create another method over here. We could call it public static void add fake car. Let's see, public static void. Let's make this an automobile. And we could say this returns new automobile of type fake. This is a horrible example. Fake SUV. Right? And then down here, you could simply just say my collection dot my cars add fake car. Right? So now I'm using a static class that creates that object, returns that object created in memory. Right? You guys understand how that works? Okay. All right. I'm going to jump back to the slide here. You guys ready? I know some of you are still pointing at the code. Okay, we're going to jump back. All right, so this is a good slide. By the way, these slides are in this week's lesson. Please go back and review them. They're a good way to kind of capture some of the highlights. Static versus non-static. So static is the keyword that's used as an adjective to describe the method, the class, the instance variable. Static fields in a class are called class fields. Static methods in a class are also called class methods. When you use a static field or a method, you do not need to use the object. So you're just accessing something that's not really tied to the RAM itself, memory. When you create a static method, you instantiate 100 objects, not only one copy exists. Let me back up. When you create a static method and instantiate 100 objects, only one copy exists in memory. That one will probably blow your mind a little bit. It's a reference to itself. It's unique in memory. okay? Because it's immutable. It's static, right? Static classes and static class variables are not instance variables. So a common way we would use static class variables would be with the final keyword. We'd make something final, making it a constant. Typically, that's what we do. We'd make it static final or final static string, right? We make it a constant so it's immutable. Can't be changed. All right? Non-static. Unless you declare a field or a method static, it is non-static by default. Right? Non-static fields in a class are called instance variables. Right, we covered that. Like in our automobile class, we have string model. Even though we put the access modifier as private, it's still an instance variable. Non-static methods in a class are called instance method. Okay? When you use a non-static field or method, you must use an object. Example of that, we have a static method. I can't just use automobile list here. I can't just say automobile list. The only thing I can use in that is these two static methods. And I'm never going to call the main method itself. That's illegal. But the only thing I can call is add fake car because that is static. Otherwise, I can't use it. The only way I can use it is I have to use the instantiated thing in memory. Okay? Inside of a static method, you have to instantiate or use the static if it's available. All right. When you create a static method and it creates 100 objects, those are uniquely 100 objects that now exist in memory. Okay? Okay. All right. Any questions so far? I know some of you, your eyes are glazing over with this because you have no idea.
No, I don't know.
Yeah.
I meant like I understand.
Yeah, Cherry.
What does that non-static use for? Like,
What is non-static fields used for?
like why is a thing?
Well, because we, if you create, let's look at this, what it's saying here. When you create a static method, that instantiates 100 objects, only one copy of that object exists.
Okay, that's
So I couldn't create an object like a person and then be able to change that object in memory. It's impossible because only one exists. If I want unique properties of a person or an object in memory, I have to create it as an instantiated object, not as a static object. Okay? Now, again, there are reasons why you'd want to do some of these. In some programs, you want only one instance of this thing to exist ever. Okay? And those immutable type objects, those are best created with some type of static class. You have the class itself that creates itself as a static object, and it itself can only exist in memory. Okay. I don't want you to get caught up too much on this, but just keep in mind that static, the only way you can create it is it has to have static in front of it. Non-static means it's instantiated in memory. You create it through the new constructor, whatever that constructor name is. Okay, you guys good?
Yeah.
Try to keep those two at the most basic level separate. All right. Creating instance methods in a class. We just did this with the automobile class. Let's go on. All right. We have not extended something yet. Explain what it means for a public class to be extended. Why would a programmer extend a class? Let's go back to our code. Let's create a new class, guys. Up here at the top, we're just going to create, instead of automobiles and things like that, let's create a person. Okay? And this person is going to have a private string first name, private string middle name, private string last name, private int we'll just do age. Okay? Now, to keep it straight, we're going to go ahead and generate a constructor. And I want my constructor to use all four of these properties. Okay? So I have a person. Now, let's go back up here again. We're going to create a new Java class. Does everyone have this so far? The person? Okay. Now I want you to think about this in terms of types. What are types of persons? No, that is an attribute.
Maybe like adult or child.
Let's think more. Let's think more like in terms of roles. So let's break it down to geometry real quick. Okay. A square is it's a rectangle, right? But a rectangle is not a. All right. Right. A square is a shape, right? So is a rectangle a shape? So now we have a hierarchy, don't we? Parent-child hierarchy. So let's think about persons in this sense. Person is kind of a low-level data object. All right? So we're going to create now a higher-level data object that is a person, like a student. Right? A student is a person. So what I could do is I have this functionality called extends, and I could say student extends from person. Okay? Now IntelliJ is going to complain here, and the reason it's complaining is it's the constructor. So we have to create a constructor that matches the person. So we'll say student, and this is going to take what? String first name, string middle initial, string last name, int age, right? And this uses super. We pass in first name, middle, last name, and age. Okay? And the super class of student is what? Is a person. Make sense? We could use, you have to use it in Java. Okay? You have to say super to refer to what it extends from. But what we have basically here now is a student that extends from person, right? And we could add some other attributes. Well, what's an attribute that's different from person that a student has? No money?
You could add like a booty
A worker?
no sleep.
No sleep?
Yes.
Okay, well let's talk about not the negative qualities, but we could say something like private, long student ID. Does that make sense? Not every person has a student ID, but every student should have a student ID, right? What's something else that a student has that's unique to a student? Person could have transportation. Well, what is it that makes you a student other than? There you go. Someone said it. Degree, right? So we're going to say private string degree. Or let's not do degree. Let's do major.
Yeah.
Right? All right. So I have my constructor down here. Now, here's the interesting thing what we can do. We can go ahead and say, I can add to my constructor, and I could say int student ID and string major. It's getting kind of long, so we're going to do this. We'll hit enter after the commas to make this more easier to read, okay? If the super constructor is setting those instance variables inside the person class, I still need to set the instance variables for this class, right? So I would say this student ID equals student ID, because I'm taking the property here and assigning it to the variable here, right? These items inside the constructor signature, those are properties. It's a good idea to kind of separate it in your head. Don't call them variables, call them properties, right? Those are the properties inside the constructor. And the instance variables are down here. So I assign the property to the instance variable. So the other thing it's missing is this major equals major. So now, if we create, right? Now this student will automatically create behind the scenes the person, right? Okay, this is important so far what we've done. A student is a person, but this gets to a very crucial relationship, and I'm just going to type it in here as a comment. Is a relationships versus has a relationship. Okay? What is the difference?
I think the first one is checking whether or not it is, and the other one's like checking if it exists.
The first is an identity. Second is an attribute. Right? Think about it that way. A student is a person. A student has a major. Right? What is something else a student has? Student ID. Okay? Now we could take this even further. let's go back over here and create another object, okay? Let's call this, address, I'm sorry, let's call this contact information. And in here we would have private string address 1, private string address 2, private string state or province, private string country, private string zip code, right? Actually, the naming of this is not good. Let's change this and just make it more specific. We're going to refactor this to be address, right?
Sorry, sir, what option was that called?
What I just did,
Yeah, the option that you showed.
refactor.
So that changes the name of the class as well on the.
Yes, changes the file name and the class name.
Refactor and what?
So you right click, go to refactor, and then rename. Otherwise, you have to,
Delete the whole thing and restart it.
yes. Okay, does everyone understand why I made that change?
It's easier.
It makes more sense, right? Because you could have multiple addresses, right? You could have your home address, you could have your work address, you could have, right? All right. So let's go back now to our person. Ask the question, is a person an address?
No, it's a person.
Or person has an address? You guys see the key here for asking that question then. So what we would do then, we could say private address home. And I'm going to do the same thing I did to my person, my other constructor. I'm just going to lay these out like this, okay? And then I'm going to say my property type here is address home, okay? Now let's go back to the we could also add another one to our student, to our person. Let's say private address work. Does it make sense? I mean, if you think about it as far as variable types, this variable type, these are both the same thing. They're strings, but yet we understand by what we're going to store in it in the name, right? So this is a person has a home address. I'm going to just change that to home address. A person may have a work address, right? So I could come over here now and I could say address work, and then down here, whoops, take out that other comma. Down here I would say this person home address equals home. This work address equals work. Okay, does this make sense to everyone? All right. So key things to remember: is a relationship, has a relationship. Okay? Now, my constructor here has changed. So what do I have to do? Well, if I'm not going to provide it, I could just say null. By the way, that's very dangerous. Okay? But I could just set it to null because I'm not providing it. Or I could have my information up here as well that provides that information. Right? I would most likely just put it in my constructor, my student constructor, and then apply it to my super constructor is what I would do. Unless there is like another special type of address, which is possible. A student could have, this is a valid scenario, right? That's a valid scenario. So now, when you would look at the data for this person, you could probably have, let's go ahead and add it just so we're clear. We have address home, address, addrew, work, address, residence hall. And then down here for the super, I'm going to go ahead and just hit enter here to bring it down. We'll say home, work, and then down below that, I would say this residence hall equals residence hall, right? All right, does everyone understand what we've done so far? Does seeing it help you kind of connect the ideas?
It helps clear that.
Okay, let's go back to the code if you guys are ready. We got about 10 minutes left before I have to run out of here. Okay, let's go back. So we've got 4.2. Do you know the instances now why you would extend a class? You have to ask that question first before you ever extend a class. Is this an instance of has a relationship or is a relationship? Okay? Has a or is a?
I want to say it's has a because let's say the user input it doesn't pertain to like everybody, you know, and so it's looking for exact information in certain points. So it could like maybe differentiate that information regarding each input, and if they do have that information, then it would further differentiate that
Yep.
extension.
Yep. So a residence hall address has a relationship or has a residence hall. A person doesn't have that. Yeah. Okay. Mutator and accessor methods. An accessor method is those that begin with get. Mutator are those that begin with set. And the reason they call it mutator or accessor is they don't necessarily have to begin with set or get, but that's good practice. Okay? It could be something that changes a whole bunch of other properties. That would be technically a mutator method. Okay? All right. And you're at the end of, we've already talked about all this. Abstract data types. Yeah. Primitives. We talked about constructors. Okay, primitive data types. We talked about the this reference. We didn't talk about, you cannot call this as a way of calling the constructor. Can't do that. Okay. Cannot call this from other methods in a class, only from constructors. Okay. Static fields. All right, so a non-static final field means it can't be changed. A static final field, it has to be set at the declaration. You can't set it later on. It has to be set at the top. So an example here would be, I want you to notice what happens when I comment out this code. Nothing, right? But if I say final it complains. Final ensures that it can't mutate, that once it's set, it's set. So when the object is created, it can't mutate no matter what. So the way you get around that is you have to set it in the constructor. Once you set it in the constructor, it's done. In fact, this is the preferred method. If you're not going to be using a setter and it's only constructor creation, make it final. Okay, make it final. Okay? All right. I think that's it. Library classes, java.lang package. We've already talked about this. If the package is not available, you have to use an import statement at the top and use the package name. Really, these packages are nothing more than folders within folders. Okay? And so you're using the dot syntax for drilling down into the folder of the package. Java.lang is the default package and everything's made available. So you don't have to use import java.lang string, import java.lang for the other. It's already there. Okay. All right, so you have the math. You guys used math when you did the math.random. You guys remember that? Okay. I'm going to stop here, and let's go back to talk briefly. We got 5 minutes. Our scenario. Okay. This is your opportunity to ask me a question that you need help on right now.
I'd like to ask for something.
Okay?
I'd like to ask for an extension on the project for next week with considerations for Valentine's Day, considering that it's I don't know how to explain to my girl that we're late for a reservation when I have to make this whole budget for Kagman.
Okay. The cutoff day is February 15th. Is that Valentine's Day?
It's 14th. You said it was on the 14th that it was due.
Oh, it is. All right. So we'll change it to the 17th. I think the 17th is
Oh, because Bill wants to have the date on time.
I don't know how to explain to my girl that.
all right. So the due date is the. All right. So listen up. Due date is the cutoff date. Okay. So I'll do that for you guys.
Oh, wait.
Thank you, Mr. Rogers. Happy Valentine's Day.
You're welcome. You're welcome.
Everybody get chocolate for Mr. Rogers.
If you want to get me something, you can get me. I'm just kidding. I about said it though. I love Cherry Garcia, and I can never find it on this island.
Oh, is that the...
No. All right. Seriously though, looking at the project code, let's ask some simple questions here. Some of you have already like turned in 90% of it, and it's already done. Okay, you've like showed me screenshots of it. I'm like, you're done. Okay. There are some things you could do to make this easier. For example, if you want to research on how to do a loop, you know that you're going to have to do the loop 8 times, right? 4 years with 2 semesters per year. That's 8, right? My math is correct, right? 4 times 2 is 8. All right. So you know you can create a loop that asks the question 8 times. Or you could do a loop within a loop, right? You could do a loop 4 times that asks a particular question 2 times, right? Enter your semester, enter your year, enter your GPA for year 1, right? Or enter your GPA for semester 1 of year 1, okay? Other things you don't have to loop. And then once you get the data, like one of the things you could do is you could actually store your data in Does everyone understand what that means? That's an array. We haven't talked about arrays yet, but this is a good opportunity for you to kind of stretch your research skills and look out how to use it. You could do this as well. Right? And so when you input the data, depending on where you're at in the loop, if you're at iteration 0, then it would be 0, right? Remember, arrays go from 0 to the in number. So if it's 8, it's 0, 1, 2, 3, 4, 5, 6, 7. If it's 8 in the array, then it goes 0 to 7. Okay, that's how arrays work. If you want to do that. Or you could type out 8 GPAs. Okay? It's all up to you, but you just have to do the calculations as well. All right? The other thing you need to look at is so you need to look at print formatting, okay? And what I'm talking about specifically is down here. You're going to notice that this stuff is formatted in a very specific way. Okay, so if you look at or do research on formatting output with printf, okay, there's tons of content out there that talks about it. Or, you know, you can go, okay, well, space, 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 space. But it's going to change every time depending on the types and sizes of calculations, right? All right. Guys, that's all I've got today. It is 4:55. I'm going to be over in the other classroom. If any of you need to chat with me and you're stuck on a problem, we can look at it there. Otherwise, Mr. Malley is going to be in here in just a few short minutes.